Hello, it's another exciting video. This time around, we are doing physics. Now, remember, under physics, we are on a topic which is called moment. Now, to be specific, we are going to consider having some calculations on what we call principle of moment. Remember that principle of moment states that for a body to be at equilibrium, the sum of clockwise moment must be equal to the sum of anti-clockwise moment. Now, remember that the SI unit for moment, which is the product of force from the line of action, which must be perpendicular to the point where the force is applied. This should be in Newton meter. So now, we have been given the question here where we are told to find the value of the distance, having given 3 newtons this side and being given 10 newtons this side. From the point of action or the pivot, we have the distance here, which is 3 meters. Now, remember that according to principle of moment, we always consider force 1 must be multiplied with distance 1, and this one must be equal to force 2, which must be multiplied with distance 2. So now, what we are going to do is, we are going to integrate the numericals here. We are going to say, this is force 1, and this definitely will be distance 1. And if this is force 2, definitely this one, the distance we are looking for, must be called distance 2, from this point up to this point. So now, with everything that we've done, remember that we are going to get and consider having this number. So, force 1, we are going to put 10 newtons times distance 1 from the pivot up to the point of action, which is perpendicular, is what we call 3 meters, which must be equal to force 2. We've been given here, which is 3 newtons. We are going to put 3 newtons. Remember that the distance from which is perpendicular to 3 newtons is the value of d. So, we are going to put dA. Now, simple mathematics. Remember that 10 times 3, we are going to have 30, which is equal to 3 times d. We are going to have 3d over a 3 and over a 3. 3 and 3 will cancel, and distance, which is perpendicular to the point of action, is 3 into 30, which is going to give us 10. Now, remember that distance here must be in meters, so we are going to say 10 meters. By doing so, we have applied the principle of what we call moment. Remember that the application of principle of moment in this example will help us to understand the physical calculations that we can encounter on what we call moment. For now, it's a bye-bye. Stay tuned.